Hello everyone, this is Bryan and this is the Soundex final that I chose to do. The point of the Soundex final is to take a list of all the top names. We have a list of about 90,000 names. It converts each name to a Soundex key, and that key is, or the Soundex key is basically it's based on the sound that the name makes when you say it. And then of those keys and names, it puts them into a sorted dictionary, sorted, and that way you can kind of see which names sound like what, and you can see which ones are very familiar to the one that you entered. And so for this final, um, we are using multiple classes that we've used in class this semester. The first one would be the array list, which is fairly simple and it should be something that we're all familiar with. And this is pulled pretty much from our classwork. Um, there are methods in here that we're not using, but again, this is pulled from the work we did in class. With the A list, I also had to use the sorted A list. This is used to sort lists of names, as you'll see in a minute. And for this, we only needed the add and remove method. So it adds names and sorts them when they add them into the array, and we can also remove names, but we're not using the remove method here. It also inherits A list as its superclass. So from there, we can go into the sorted dictionary. The sorted dictionary is also something that we should be familiar with, and it has an array list of keys and values. As you'll see with this project, the values array list is actually our V for it is a sorted A list of type string. So that we'll see in the tester file here. So going on to the project, we have a surnames list of 90,000 names. Those names are each read and converted to a Soundex key using this Soundex keymaker file. The Soundex keymaker reads through each name letter by letter and converts it to a string of numbers. And then that string of numbers is ran through this 5-step algorithm to then get it into a 4-digit or 4-character string, starting with, I'll show right here on my cursor, usually starts with a letter, so B for example, and then 3 numbers following. And that right there should categorize it based on the sound that it makes when you read it out. So going to our tester file, which is our main, got a lot of imports here, and we start by initializing our text file, which is surnames.txt. We also create a sorted A list of string. I called it Soundex, and this is what's going to hold each name or all of the names for each specific Soundex key. So there's going to be multiple sorted A list of strings. And then right below this on line 21, we create the actual sorted dictionary where our keys are just strings, or they will be array lists of strings, and the values will be array lists of sorted A lists of strings. So again, our V is exactly what's highlighted here. So looking back here, it's going to be an array list of V, where V is sorted A list of string. A little confusing. Anyway, on from that, we have count to key and max count. These are used for bounding issues, or to make sure that there's not bounding issues when we print out the names. The purpose of this project is to read in a name from the user, convert it to a Soundex key, print out all the names associated with that same Soundex key, and 5 above and 5 below. So that way you can see some that are similar um, in both directions with their sound, which we will see as I run this. Below this, we have a try catch. The try is what actually reads through the surnames txt. As we can see here, there's a scanner that we initialize, and while the input file, which is surnames, has next, we read in a surname and junk. So surname is going to be just the first part of each line here, and junk is going to be the numbers afterward. The reason I read in junk is just to get through the line. We don't actually use the junk. We're just using it to be able to get down to the next name. In this case, it's Johnson. So doing that, every name is read into surname. Each iteration through this loop converts each name one by one to a Soundex key. And then we check if our sorted dictionary already contains that Soundex key. If it does not, we create a new sorted A list of string. We add it to that sorted A list and then add that sorted A list temp in this case to the sorted dictionary, which is called Soundex cache. We add its key and the sorted A list for it. In doing this, we also increase max count, which keeps count of how many keys are in our sorted dictionary. After that, we have an else statement. The else is saying that if that name is already, or if that Soundex key is already in the sorted dictionary, we're still going to create a temp sorted A list. We're gonna assign it to the already existing sorted A list of names for the existing Soundex key. We're going to add our name to that existing list and then re-add it back into the sorted dictionary, basically overriding what was already there. After that, we close reading the file because there's no point in reading it anymore. We're done with that scanner. And we have a catch just in case the file entered is incorrect. So after that, we initialize our scanner. This is what takes in the user input. I have it casting to uppercase or lowercase, whichever is preferred for this project. I found that uppercase works just fine. And then it converts that user entered name to a Soundex key, prints it out, or prints out the Soundex key for it. And then we're also printing out the entire list of names that sounds like the one that's entered. After that, I have this while loop here. This is just to find out what position your entered name is in the entire sorted dictionary. And after that, we initialize a key iterator. And this key iterator is used to iterate through every single key of the sorted dictionary, which is these guys right here. And then based on where we are with the bounds, we will print either 5 above and 5 below, which is this chunk right here. We will print just 5 below and how many are left above it if we're at the top of the list, names starting with A. Or if we're at the very bottom of the list, a name with Z, or it sounds like a Z name, we'll have to just print out how many are left after it and 5 before it. So now to show some examples of this running, I'll go through each of these printout checks here. Actually, before we do that, I can just, let's see. I believe this should just print out every single key and name list with it. And just to show that it is working. So I enter in my last name. Yeah, cool. So there's 90,000 names being read in, so it's about 4,600 different Soundex keys here. And what I just had at test print is every single Soundex key sorted, and every sorted A list of names, which, as the name implies, is sorted as well. Which, as you can see, it is sorted ABA, ABB, ABE, and so on. And it does that for every single Soundex key. So undoing what I did here, we can show that it is working. So to enter a name just in the middle, I'll just enter my last name, Barry. So we have it printing my last name that I entered. We've got the Soundex key with it and the names associated with that specific Soundex key. I can actually bring this over. And we're just looking at the top line right now, the highlighted one, and this goes for quite a bit. Got all the names that sound like Barry. Going down here, we have the B600, which is the Soundex key for my name, and we're printing 5 above it, which are 1, 2, 3, 4, 5, and 5 below it, 1, 2, 3, 4, 5. So that's showing when there's no issues with bounding when we're printing. Now we can check top bounds. So a name starting with A. Here's one that's up there, is that. This name is a very top name, and as you can see, we print that name along with the 5 after it, none before it because there are none before it. And for the other situation, we're at the other side of the list. We want to print out 5 before and just however many are left. So that name would be Zer Miller. Okay, so here's our Miller name printed out up here. It printed out the whole list of it, which is just Miller. We've got 5 above it, so 1, 2, 3, 4, 5, and there's just 2 left below it. And this, we can show that that is correct just by doing this. Oh, that's the wrong if statement. Actually, for this project, there was 2 guidelines we could have gone by. One was just the very start print, where it prints out your name and the associated names with that name. And the other option was to do the 5 above, 5 below. And I did choose to do both of them just because I thought the project was cool. So again, with Miller, here's the very bottom of our sorted A list or of our sorted dictionary, and you can see there's only 2 below. So it did print correctly. So that's pretty much the project. Go ahead and take a look at it, and yeah, thanks for watching.